Hello everyone. Uh, I'm Rohit Kharat and I'm pursuing my master's in mechanical engineering from University of Colorado Boulder. And I have taken a course called computer vision from computer science department. And I was looking into uh, recent research which is going on in computer vision, and mostly this is related to in some sense in medical technologies. And I was like hoping to give some knowledge and share my insights, what I have found in reading that research paper. And so the research is mostly uh, using computer vision to identify images down to pixel level. Previously, we have traditional computer vision systems which like do object detection and object segmentation, but that uses like labeling of bounding boxes, and it's a very human intensive approach. And like there are many errors which are prone to happen because humans are doing the labeling, and mostly humans lack some knowledge in kind of like some in biological domains or like astrophysical domains. So like the MIT researchers have found a way that we can minimize those errors in prediction of like what kind of objects are there in the image. And we'll just move forward like how they have come to that algorithm. So like we know that like for humans, it is very easy for us to identify items or objects in a scene. Like we know that if we see an image, we know that the image contains a picture of a cat, or if we have an image of a road, we know there are pedestrians or vehicles or trees. So it is very easy for us to comprehend the scene and objects in the image. But when it comes to computer, it basically goes to a pixel levels, and we try to find what pixels are there and how we can use that pixel knowledge in order to comprehend what image that would be. So in this image, we see a grayscale image which mostly contains values ranging from 0 to 255, and like we are able to comprehend that it is the image of Abraham Lincoln. Like even without the image is not that clear, but with the help of pixels, we are able to comprehend that it's the image of a person. So further going on, this is a grayscale image, but if you want to go for like a color image, so mostly there are three channels in that, red, green, blue. And so like all the three channels have pixels in there, and we are able to get more information about the level of depth through that image because of the channels. And so moving forward, how algorithms have been developed in computer vision. So if we get an image of like this image, so like for artificial intelligence or for computer vision systems, the task is to understand the objects in the image or identify the scene in the image. So it takes a lot of effort for a human to manually label those image. So lot of time and lot of expense incur in labeling those images. So a human, what it does, he has a bunch of images, and he uh, draws a bounding box in those images. Like if you want to detect a car, so he will draw a bounding box to a car, and like there will be several thousands of images he would be doing the labeling of. And that's why the researchers were hoping that we should have a more robust kind of algorithm which would able to detect those objects in the image without having any human intervention, and we would be having less labeling errors. So in the image, the algorithm is able to effectively identify and as well as segment the objects in the image. So we are able to see that the image has been segmented well in terms of vehicles or pedestrians, as well as buildings and trees. And so moving forward, how the MIT researchers are approaching to this scenario where we want to minimize the labeling errors. So they have come up with an algorithm in collaboration with Cornell University and Microsoft, and they have developed an algorithm called STEGO algorithm, which is called self-supervised transformer with energy-based graph optimization algorithm. So what it basically does, it uses, instead of using traditional computer vision systems, which does the labeling of bounding boxes, what it does, it uses AI in the backend and tries to identify images with the help of each pixel. And they do that with the help of large amount of data sets. And the AI in the backend is able to comprehend that with the help of a single pixel, they are able to comprehend that it is that the image contain a cat or the image contain a pedestrian. So, so this gives a more accurate view of the world in terms of image, and we're able to comprehend well that the what the scene would be whenever like we give a new image to the algorithm, and the algorithm is better able to construct a consistent view of the world with the help of images. So after going forward, like how this algorithm is able to do well in terms of various data sets. So the researchers tried this algorithm on driverless car data sets, and the algorithm was successfully able to segment out roads, people, and street signs with much higher resolution and granularity than previous computer vision systems, as well as when the algorithm was fed with images from space taken from aerial or satellite. The algorithm was very well able to segment each single square foot in the image, and it was able to well segment roads, vegetation, as well as buildings. So in the image, we can see that even if the algorithm was given aerial or satellite images, it was well able to segment vegetation as well as roads in the image. And in doing that, there was no human intervention, because traditional computer vision systems had to do labeling of the images, and it takes a lot of hours to do that and a lot of errors, because if you want to detect a particular, let's say, cancerous tumors, if you want to detect through computer vision, it takes a lot of time to do and a lot of domain knowledge in order to detect what type of cancer that would be. And this leads to restriction in some sense for the human as well, because that can lead to error if the person is not having some domain knowledge in that case. So moving forward, like we know that this algorithm is very well able to do the labeling part without any human intervention, as well as the researchers were able to prohibit some cost in doing that. But these algorithms have some kind of limitations in them. Let's say if we have an image which contains some food stuff, let's say it has an image of pasta or porridge, but still the algorithm detects them as food stuff rather than giving more depth as to what kind of food stuff that is. So this limits us into getting more insights from the image. That's one drawback of this algorithm. And the next drawback we have is, let's say the image in the upper right corner is an image of a pineapple shaped cake, but the algorithm confuses itself, and it detects it as a pineapple. But as we know, as we are humans, we know that it is a pineapple shaped cake, and the algorithm fails in that case. So the team is having future work, and they have scope in order to do more iterations in the future to have a system which would which would able to detect and identify objects with much more classes, and like we wouldn't have to we would able to build a computer vision system which would in the future able to recognize the scene as well as in the object without using humans. And this technology would be really helpful if we have a driverless car, and as well as several robots. We can use this technology and algorithm to build more robust computer vision systems. So that's all from my side, and I'm happy to have any questions from any of you.
Any questions, people?
So, from my side.
All right, I have a question then. So you mentioned about the use of this technology in identifying cancer as well. So can you throw some light on that, please?
Sure. There is a task and research going on to detect breast cancer, and like there are several types involved in breast cancer, and the researchers mostly focus to detect cancerous tumors which are benign and like which are non-benign. So we have several types in that, and how computer vision system works in those cases is that like traditional computer vision system does the labeling of the cancerous tumors, and they segment and classify those images separately into like type 1, type 2, type 3, type 4, and like there are several types, and they classify them as benign and non-benign. So like this takes a lot of time, and if a person who is doing the labeling is not aware of what type that cancer is, that would probably lead to misclassification of that image, and that can lead to computationally that would be intensive, because the surgeons or who will be going forward with the surgery, they will having wrong information about the cancer, and it would lead to unnecessary medical
harms
going forward to the medical classification. Yes,
certainly. How about complementing it with artificial intelligence? And speaking about practicality, how practical is it, for instance, to have it in remote areas of India, for instance, since you come from India?
So we obviously need to have more robust computer vision system. We need to have more data sets, and like this algorithms work basically with the help of data sets, and we need to have strong and well resolution images in order to give to the algorithm. So in practicing that, whoever is going forward with the research, they should have a big or a good planning of collecting those data. If they want to capture the cancerous images, they should have a good system in order to capture those images, and that comes mostly into medical technology, how they capture the images, and integration of a person who is doing the algorithm, and the integration who have of a person who have the medical knowledge, that would be really beneficial, and that could help with the building of artificial intelligence in medical technology.
All right, thank you really very much. Do you have any questions, people? No? All right, thank you very much for enlightening us on this interesting topic.
Thank you so much.
Thank you, have a good one. Bye.
Yeah, you as well. Thank you. Bye.
Thank you. Goodbye.